Okay, my students, I apologize for yesterday. I don't know how it was sideways. I thought I had it set up the same way. We'll see how it works today. But let's see yesterday's homework. Jimmy has 5 letters, so it's 5 factorial, divided by how many repeat? 1, 2. And then 2 factorial is the same as 2 because it's just 2 times 1. So really, 2 factorial is a little bit of a waste to write because 2 factorial is just 2. But anyways, we have 5. We have 3 repetitions of a single item. So it's 120 divided by 6 because 3 factorial is 6. And then 6 factorial divided by 2 factorial, 2 factorial, 2 factorial because there's 2 M's, 2 O's, and 2 W's. Wow, Mom. Now, I personally in a calculator just put 6 factorial divided by 222 is 8 when you multiply. So I kind of simplify this if it's not bad. So like this one, 4 factorial, that's 4 times 3 is 12, times 2 is 24, times 2 is 48. So I just put 48 instead of writing all that down. 11 factorial divided by 48. Which is that huge number. Too bad JoJo is a hobo, though. Then how many different ways could 7 people sit at a round table? Well, if it's circular, you just take 1 off the total. So it would be 6 factorial, and then 10 would be 9 factorial. Now, whoops, I need another piece of paper. I thought that was blank. Oh, no. Woohoo, saved myself. Now, we're going to talk about a permutation, which is what we've been doing. And a permutation is when order matters. So whenever you're putting things in order, it's a permutation. So for example, let's look at a coach, softball or baseball, and they have 13 people on a team, and they want to make a baseball lineup of 9 people. Let's do it this way. Need 9. Now, order matters because the person that bats first is different than the person that bats second. So, you could do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then go 13, go in the first spot because you have 13 choices. Then one's gone, and then another one's gone, and another one. Another one, another one, another one, another one. So, then multiply all that together. That's fine. Or the permutation formula is n factorial, the number of items, divided by n minus r factorial, where you go the number of items minus the number of items needed. So n is the number of items, and r is the number of items needed. So in this case, you would go 13 factorial over 13 minus 9 factorial, which is 13 factorial divided by 4 factorial. Notice what's happening. The last 4, which we don't have, because we don't need, you only need 9, all that's gone, that repetition. So it would be 13 factorial, which is a huge number, divided by 4 times 3 is 12 times 2 is 24. So you could do 4 factorial or 24. And I get 259, 459, 200. So your coach goes through that many decisions or has that many choices to make a lineup of 9 people from 13. Isn't that incredible? So maybe for your homework tonight, I should have you come up with 13 names and then arrange them in a row for 9 at a time. You would just have 259 million ways of doing it. That might take you a couple minutes. Don't do it though, I'm just joking. Now, if you go to Desmos and go to the bottom where the trig is, to one of those sections, they have NPR. Now, some calculators have NPR, and what you do is you put the 13 and then the NPR 9. Sorry about that. Or some calculators do NPR and then 13.9. Like that. So, what I want you to do tonight is with the calculator, it doesn't have to be Desmos. Let's say you have 10 items and you need 8 of them to put in a row. With the calculator, see if you can figure out how to do it. Now, if you want to do it this way, fine. If you want to do it this way, that's fine. I'd rather you try to do this if your calculator has it, just to see how it works. So, I'll give you the answer here. I get 1814400 if I didn't make a dumb mistake, which last couple of days I have been. So see if you can figure that out for me, please. Using it, and that's all I want you to do tonight. So nice, easy night. That one problem. See if you can figure it out. And I'd rather you try to use one of these on a calculator, NPR or NPR and then that. But have a good night. And thank Jesus, please.